All right, so number 32. There's a couple little tricks in here. But neither, hey guys. But neither one of these. Neither one of these should give you too much trouble. You're trying to find this whole length right here. Okay? And they tell you that this is negative 285 degrees, right?
Yes.
So what's the formula for finding?
180.
So we have to change this angle measure into radians because the formula that we know, I've very clearly told you 150 times yesterday, that the angle measure has to be in radians. So how do I take negative 285 degrees and change it into radians? Katie, this is you now. We're ready for you.
Okay, pi over 180.
Okay, good. You multiply this by pi over 180, okay? Now I know when we first started doing this, you guys did the whole cross-canceling, reducing thing, but since we're just going to come up with a decimal answer anyway, we might as well go decimal right now. So you can do this on your calculator. Negative 285 times pi divided by 180. Tell me what that comes out to be as a decimal. 285 times pi divided by 180.
Negative 4.9.
Negative 4.9.
That's not what I got here.
I got 4 points.
I got 740.
Yeah, and
Basically, if you round it, it's negative 5.
Yeah,
Okay.
you can, but
Awesome. All right, I will take that. So this angle right here in radians is negative 5. So now I just have to, oh, I did that wrong anyway. S equals r theta, sorry. So the radius is,
5. And then
the radius is, not pi, the radius
What?
is,
negative 5.
wow, look at the book, look right here, 150. We figured out this angle to be negative 5 radians, but we're not going to ever give an answer of a distance in negative numbers, right? So I'm just going to change that to positive. 5 times 150 is about 750, so it's going to be about 750 feet. Okay?
we got 746.
That's the answer. Yeah, if you didn't round, you get 746-ish, which is a better answer. What?
Why wouldn't it be?
Because it's a distance that we're measuring right here, and you never measure distances using negative numbers. So if you come up with a negative number, you just change it.
Where do you get 150 from?
It's the radius of the thing.
So where did the pi over? Is it
So many questions for such a simple problem. The way you change degrees into radians is you multiply by pi over 180.
Oh,
Okay, we did that previously. You
yeah,
good?
that's why I was almost typing wrong.
What's your questions?
Can you do like one of the?
No.
No.
Okay, 33 is really, really simple because the angle measure is already in radians. So S equals R times theta. If you look in the book, the radius is 22 feet. The radians is 1.45. So you multiply those together, and the length of that hang glider, or whatever it is about 32 feet. So if they give you the angle in radians, you're pretty much done. You just have to multiply those two things together. Okay?
Cool.
All right, so let's get into the fun word problems now. 34 involves what's called a geostationary satellite. Do you know what that means?
It stays in place.
It stays over the same spot on the planet the whole time. So as the Earth rotates, the satellite rotates as well, okay? And so since that's the case, how long does it take for the satellite to make one complete trip around?
365 days.
No, because we're around the Earth, not the Sun.
Oh, 1 day.
1 day or 24 hours. So it takes 24 hours for this to go all the way around so that it can stay right over the same spot, which is probably your house. They're probably spying on you. No need to worry. You haven't done anything wrong. Okay, this satellite is 35,800 kilometers above the surface of the Earth. Okay?
And then does it give us the radius?
It does not give us the radius of the Earth, but we did a problem involving that yesterday in your notes. Oh, it does give you the radius of the Earth? Oh, the radius of the Earth is about 6,400. Okay,
This is
so
what it told us
that's
last day.
same thing from yesterday. Okay, so the overall radius of this satellite orbit is what? 42,000? 42,200? Because I just need to add these two things together, right? Okay, so the total radius of this circle is 42,200 kilometers. Okay, then it says, what distance does a satellite travel in 1 hour, 3 hours, 2.5 hours, and 25 hours? Okay, so remember that we want these measurements in radians. So if it takes you 24 hours to go all the way around, and all the way around the circle is how many radians?
1, 2, 3,
Oh, you guys are killing me.
24.
Okay, somebody help me.
Repeat the question.
Okay, hold on. First of all, yeah, you guys are super distracted today. I need you guys to focus up a little bit more than you are. Okay? What?
I don't know how to do it.
Okay, but you should know the answer to this question. How many radians is it all the way around the circle? How many radians? 2 pi. Okay, nice job. Okay, so if it is 2 pi, please stop. Because you guys are being really annoying today. You're just sitting there doing that same thing. You're having this conversation the whole time. Okay? Okay, don't go forced on me now. Just say, I'm sorry, I'll pay attention. Okay? Thank you. All right. So if it takes 24 hours for it to go all the way around, in 1 hour, how do you figure out how many radians it has gone?
Divided by 24.
Thank you. Divided by 24 because it's gone a 24th of the way around the circle, right? You're scaring me just a little bit today. I'm hoping it's because you're not paying attention. And that's why you're not. Okay, I want to go outside too, but that'll happen later. Okay, so that means the angle in radians is pi over 12. Okay? So all I need to do to find the distance that it travels then in 1 hour is take that angle times the radius, which we figured out was 42,200, and multiply those together. Okay? So that is the 1 hour distance. How about in 3 hours? So here's your chance to shine again. If it takes 24 hours to go all the way around, which is 2 pi, what will the angle be for 3 hours? Divided by 8. Yes, it will go an 1/8 of the way around the Earth, which reduces to pi over 4. So to figure out that distance, you go pi over 4 times 42,200. And I don't know what that is, but you can figure it out. Okay? All right, 2.5 hours, that's a little bit trickier. So if I have traveled for 2.5 hours, how do I figure out what, fraction of the whole 2 pi radians I travel in 2.5 hours? Yeah, so basically I'm going to go 2.5 divided by 24, because that's the fraction of the distance that I've gone, okay? And multiply that by 2 pi, and that'll be my angle. Does that make sense? Because we really did the same thing here. Here we took 2 pi and multiplied it by 1 over 24, because I went 1 hour out of 24 total. Here I took the whole distance and multiplied it by 3 over 24, which reduces to 1 over 8. What? For your science textbook. You did a great job. Okay, so this is going to be my angle. My radius is still 42,200. Multiply all that just together, divide by 24, and you're good. What do I have to multiply the 2 pi by to figure out how far it goes in 25 hours? 1 and 1/24, or I'm just going to stick with 25/24 times 2 pi times the radius of 42,200, and that will tell you how far it travels in that time. Okay?
That's a lot of work.
What?
Hours are taking up.
Well, this one was for 25 hours. This was for 2.5 hours. So that was your question? I need some.
Yes.
What units do we get our answers in?
Hours.
Nope. What?
Kilometers.
Kilometers, yeah, because we're talking about a distance here. So we come up with kilometers. Okay, B. A little bit tricky. Yeah, all this was 8. 1 hour, 3 hours, 2.5 hours, 25 hours. All of that, 8. Yeah, they're going. Okay, B. After how many hours has the satellite traveled 200,000 kilometers? Okay, so now we need to take, this is the S, this is the answer. So I have to take 200,000 instead of equal to R times theta. Okay?
Find out.
So
I figure out what the angle
our
is.
radius is
We know our radius is still
2,200.
42,200. Okay, times theta. So solve that for theta. What do you get? What do you get?
I got 4.74.
4.74?
I got 4.74.
4.74? Okay, so that means the angle is 4.74 radians. How do we figure out how many hours that is?
Well, you just put it on the little. You have to put it in degrees first.
Divided by 24?
Well, you
Multiply by 24?
have to put it in degrees.
We're going to put it in degrees. That would be, we have it, it's easier for to think about these things in degrees. But what I want to know is what fraction of the way all the way around this circle 4.74 radians is. Okay, so I'm going to go 2 pi, because that's all the way around, divided by 4.74. And tell me what you get from that.
1.32.
I did that backwards, sorry. Divide it the other way around, sorry.
Wait, so 4 point.
I need to know what fraction of the way it is around. So 4.74 divided by 2 pi.
7.4.
No, it's going to be less than 1.
I got 7.75.
0.75? Okay. So that means, what you did wrong is you have to have your 2 pi in parentheses when you divide. Okay, otherwise it'll divide by 2 and then multiply by pi. Anyway, so it has gone about 3/4 of the way around the Earth in 0.75. So now this is the answer that you take and multiply by 20, or by 24, and
So
you get
18.
18.1.
No, I got 18 straight.
I got 18.
18.1.
Whatever.
Okay, 18.5.
I'm not going to fight you over 6 minutes, okay? It's going to be okay. We're not working for NASA yet.
Is that like the next problem?
Is that what?
Is that the next problem working for NASA?
No, I was making a joke with satellites, NASA. Like this would be something NASA would have to figure out. And, I don't know where you guys are
I
at.
don't know what's happening.
Okay, 35. Okay, shh, 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 shh. Suppose a windshield wiper arm has a length of 22 inches. So this is 22 inches. And when you turn on your windshield wipers, and it makes its whole little swoopy thing here, it goes through an angle of 110 degrees. Okay, the question is, what distance does the tip of the wiper travel as it goes across? So they're just asking you to find this distance right here. okay? So it's the same formula again, but
Just put it in.
you have to put it in radians, okay? So I have to go 110 times pi over 180, okay? So 11 pi over 18 is going to be my angle in radians. So to find the length of the arc, I take the angle times the radius, and if you multiply all that out and then divide, you should get about 42.2 inches. Okay? So that is not that tricky of a problem.
Just give it one.
Yeah, I got that one.
Okay, 36.
What did you say?
All right, 36. The 24 lines of longitude that approximate the 24 standard time zones are equally spaced around the equator. So if you have, I'm going to make this drawing one way and then I'm going to switch it in a second. If you have good old planet Earth right here, okay, and then that's the equator, right? What they've done is they've taken and divided this up into a bunch of pieces, right? Right?
Yes.
Girls?
We use 12 lines, right?
Those two girls.
We use
Okay.
12 lines, right?
Wow, you guys are so weird. It's like,
You just carry that much.
it's just weird. It's just weird because it's not like Pua never talks in class, right? And a lot of times she talks in class and I never say anything about it. But if I dare accuse her of talking in class when she's not, it's like,
Anybody does
The world
that.
knows.
you're going to fight.
I was trying to focus, and I just
Yeah,
got.
I know, but you know, it's like, what? Let it go. All right, so does that make sense, the 24 lines of thing? Okay, so now we're looking,
You do a
Now
little
we're-
songs with your shoe shit sometimes.
huh?
You do a little songs with your shoe shit sometimes.
Anyway, now we're looking straight down, okay? So this is, we don't need this equator anymore. Now we're looking straight down at the equator of the planet. And we're taking this and we're dividing it into 24 pieces. Does that make sense?
Yes.
Okay? So these are the, yeah, it's like a pie. So we're looking straight down at the Earth, but we cut the Earth in half, and so we're seeing how these lines of longitude divide the Earth up into 24 separate pieces, okay? So it says, suppose you use 24 central angles to divide a circle into 24 equal arcs. Express the measure of each angle in degrees and in radians. So this is how many degrees all the way around?
360 divided by 12.
Okay, divided by 24.
Which is 15.
And so each one of these little arcs would be 15
So we
degrees,
put it in
okay?
radians.
Then it says also express that in radians,
So times by 1.
okay? So I have to take 15 times pi over 180. 5 goes in here 3 times, 5 goes in there 36 times, 3 goes in there once, 3 goes in there 12, so it's pi over 12, which you can figure out is a decimal if you feel better about it that way. Okay? So the measure of each angle in degrees is 15 degrees. The measure of each angle in radians is pi over 12. Okay. B, the radius of the equator is about 3,960 miles. All right, so we are supposed to figure out how wide each time zone is at the equator. So what formula am I going to use?
We know the radius.
We know the angle in radians,
And we know
okay?
the
We
radius.
know the radius, so I just multiply those two things together.
And get a decimal thingy, right?
Uh-huh, and you get a decimal thingy, what is it?
9, 6, oh gosh.
1,036.7 miles, okay? Does that make sense what I'm doing?
Yes.
Okay. All right, so now if we take this cross-section of the planet and we move up the planet a little bit to the Arctic Circle, But we still have taken it and divided it up into 24 equal pieces because those run around down the side of the globe. But now since we're up at the Arctic Circle, this circle is a lot smaller. Yeah, now the radius is only 1,580 miles.
But the angle is still.
But the angle is still going to stay the same, yes. So to figure out the length of each one of these, I do the same thing. But I just have to change the radius to 1580. Okay, and so a time zone at the Arctic Circle is only 413 miles wide. Okay, so if you're at the equator and you're driving somewhere, it's going to take you over 1,000 miles to get from one time zone to the next. But if you're at the Arctic Circle and you're driving somewhere, you only have to drive a little over 400 miles to get into the next time zone because they're much skinnier up there. Okay? All right, you guys turn those in, please.
Yeah, that was a